So the main reason why I want to give this talk, so yeah, this is a piece of work I did maybe 6 months ago, um, prior to our last procurement exercise for this Ceph cluster we run. And I think the main reason why I want to talk about it is I was somewhat surprised by the results. And so really I'm hoping someone's going to tell me what I've missed. But or if people may find some enjoyment from the results like I did, or at least some interest. So I'm going to try and give the bare minimum amount of context because context is boring. So yeah, so we run a bunch of Ceph clusters here at the Science and Technologies Facilities Council. Echo, as we call it, is the largest one we run. So it's it's over 100 petabytes of raw capacity now. The Ceph cluster itself is nearly 9 years old now, so it's getting up there. It's lasted well, I guess. That's what we can say about it. It's all of the data storage pools are EC 8+3. There's over 70 petabytes of stored data on it now, and most of the time I'll go into more detail about the access patterns, but most of the time it's sitting there doing several tens of gigabytes per second of transfer rates, mostly reads. And what it's doing is, as I said on the title slide, it's supporting high throughput computing for the LHC experiments. So I'm not a physicist, but the computing and the storage that goes into supporting LHC science is really there's the raw data that's coming off the actual detectors. There's then simulated raw data, which is effectively there's a physics model which they run Monte Carlo simulations against and produce raw data files that are from a simulation. There's then a bunch of reconstruction to turn them into what the particles were actually doing inside the detector, whether it was simulated or real. So you get your analysis object data, and then you do your analysis. You compare those things, look for statistical significance, and all of that. And then you get science out of it, or you get papers out at the end. I think that's how it works. So anyway, so this Ceph cluster is sitting close to about 50,000 cores of compute that is effectively just doing the simulation and the reconstruction, which is the sort of the big production workflows, and then supporting the user analysis that happens after that. That was interesting. It just went on to the next slide without me pressing anything. Cool. Anyway, so yeah, so in terms of, that is the next slide. Yeah, cool. So in terms of data access, all of this happens through effectively a custom plugin. So the data access all happens through something called xrootd, which is sort of, you can think of it as a combination of, I guess, curl, a web server, a bunch of other stuff, plugins to underlying file systems, and a framework to build build a sort of a data access pipeline from the underlying block devices down to like how the analysis code is grabbing the data off remote storage. And so there's so xrootd is the thing that's mediating all of that, and then there's a fairly lightweight plugin which is allowing that to plug directly into a Ceph pool using librados and using librados striper on top of that. It is, by its nature, it is incredibly simple. It doesn't support like full file system stuff. There's no directory listings, etc. You can put files into a location and you can get files from a location, which means we have basically no metadata load, which is useful, or at least makes it easy for optimization. We control IO fairly, or like IO sizes fairly carefully. If you look at the bottom plot on the right, like most, sorry, I don't know why it keeps switching slides. That's annoying. Most of the like this is just read sizes. It's either 64 megabyte, 32, sorry, 64, 16, or 8 megabyte, with a relatively small amount of sub megabyte access. So we sort of make really heavy use of prefetching into like application, and again, this is all in XRD, into the application layer caches, to make sure the IO actually hitting the Ceph cluster, hitting the hard disk drives in this case, are large enough to be efficient. And as you can see from the data rate, and this is just the information coming out of Ceph, we're seeing a fairly steady sort of 20 plus gigabytes a second of reads coming from a mixture of like other sites around the grid and the local compute cluster. Okay. I should say, please ask questions. Please interrupt if you want. I can't see hands, so you'll just have to start talking and I'll stop talking. Cool. So in terms of hardware spec for this cluster, as you can tell by the size, in fact, it's over 100 petabytes. Like this is there is a need for capacity here. The way how this science works, there is a need for a fairly large amount of online disk storage. And so the primary aim here is capacity for cheap. And that's, I think the hardware kind of reflects that. Mostly we end up with 2U servers, sort of the Dell XT2s or whatever the Supermicro and other equivalents are. Yeah, so that sort of form factor with as large as reasonably possible hard drives, depending on when we bought it. So it's normally not quite the biggest hard drives, but it's pretty much the biggest hard drive you can get in whatever year we bought that generation, because that's the cheapest way for us to get the capacity. And as I say, this is like a multi-generational cluster. We buy about 20 petabytes every year, so sometimes it'll be 10 petabytes, sometimes it's 30 petabytes, depending on how much money there is available, versus buying other stuff for this project. But yeah, so we're buying a fair chunk of hardware every year, and it goes out to tender. So we can't control exactly what we're getting, and as I say, usually the most efficient way to meet the requirements is just with big hard drives in these 2U chassis. When we started buying it, or when in the first years of procurement, we didn't have the money, and we also maybe didn't quite realize the importance of having Flash for write-ahead logs, databases, etc. And in general, this hasn't been a problem, but I think we're in an interesting situation now where obviously we have this giant Ceph cluster. It's got 5 different generations of hardware running in it right now. It would be a really big task to retrofit Flash into it. There's different hardware specifications, different amount of hard drives. Some of them don't have space for Flash, some of them do. Yeah, it would be a big job to make this change, or it would be a very slow job to make this change if we were to wait for the generations to age out. So it's something that we need to think about. But yeah, so, and to sort of finish up the context, what we do have is a couple of the recent generations have some Flash in them, which was bought for provisioning a separate Flash pool for some research and development that was being done. But one of the things I had wanted to do with it for a while was to see what that would mean for, is there is there a compelling reason to have to move RocksDBs onto Flash for this use case? Which we didn't have an answer to, and we really need an answer before we started thinking, or before we could do anything about it. So I didn't have a lot of time to do this because I had left it too late. So this was really just a test in production type of thing. Redeploy, starting with like individual OSDs, redeploying OSDs with some Flash for their RocksDBs. Observe what happens, make sure they don't explode. Once I had some confidence there, redeploy entire nodes and observe changes. See what the difference is in the amount of I/O actually hitting the hard disk drives is, and then try and use that to be able to quantify what improvement, if any, we would get from starting to buy some amount of Flash with these. So yeah, I think straight onto the results really. To start with, the obvious place to start is backfilling. This was the first thing we had to do with them, and so it was the one we immediately saw differences. And so this was really just I know roughly what a HDD only OSD looks like when it's backfilling. What differences are there for a hybrid OSD on similar hardware, starting at max backfills 1 and then ramping it all the way up to underlying device saturation. And I think this was, I mean, so you'll notice as we go through the results, I went from the bits that I was like, oh, this is amazing. We're definitely going to be able to convince management to provision some Flash for the upcoming generations. But then the story kind of went off the rails towards the end. But anyway, so to start with, there's a clear difference here. And I think looking at the plot on the right, so this is the latency on the y-axis, so the latency of the underlying hard disk drive operations against the data rate that it's actually supporting. We can see the hybrid OSD doing so. Is that all good? Yeah, fine. So the hybrid OSD doing exactly what it's meant to do. That's being able to extract like the performance of the underlying hard disk drive in the way you want to. You've got your nice low latency of the write operations up until you sort of hit the maximum around 200 and 250 megabytes per second. And then your latency starts to go up as you've saturated the device. In contrast, the OSD with the co-located RocksDB is a bit of a mess. You're starting to see performance, or you're starting to see latency climb below 100 megabytes a second, which is not great. And then you sort of end up in this weird middle ground where you can get more performance out of it, but it's your latencies they're not sky high, but they're not good.
Hey, quick question. How many OSDs did you have, like a single flash drive kind of holding the DBs and walls for this test?
Yeah, so for this specific data set we're looking at, this was one OSD per. So to set the scene of where we are, these storage nodes had a single like flash device in them. So to start with, because I wasn't sure how anything was going to work, I was just doing like provisioning a single hybrid OSD on each host. And in this case, this was with a 200 gigabyte partition. As I then went on to the whole node tests, I ended up having to partition that, what was it, like a 2 terabyte SSD into however many partitions I needed to do to get 24 OSDs worth of RocksDB partitions. So for the whole node test, it's like an over provisioned flash device. I guess people normally talk about having maybe like 10 or less than 10 OSDs per flash device. But in this particular case here, we're looking at it's actually just a single one. So there's definitely enough headroom.
Cool. Yeah.
Excuse the stupid question, but can you describe the red dotted line, please?
Yes. You've spotted the thing that's not on the legend because I'm lazy. The red dotted the red dotted line is the networking limit, or the approximate networking limit per OSD. So these are 25 gig hosts, which means that for 24 OSDs on the host, each host has about 130 megabytes a second of network throughput available, assuming every OSD is doing the same thing. So obviously in this single OSD test, where the rest of the OSDs aren't backfilling, there's plenty of extra networking throughput available to allow like this particular OSD to backfill at line speed for the block device. If we were doing whole node additions, which is effectively where we really care about backfill performance, like can we get a generation into the cluster faster, we would actually we're capped at about 130 megabytes a second anyway for this type of hardware. So although it's cool that we can get more performance out of individual devices, like there's a different bottleneck we'll be hitting at the red dotted line, if that makes sense.
Yep, definitely. Thank you.
Cool. Yeah, so I think this was, as I say, this was where I was like, this is amazing. I'm immediately seeing the results I like. Yeah, it was really good to see the backfill performance be significantly better, especially in terms of the latency. It's like, yeah, this is great. I then had to start looking at, started looking at the what I would call normal cluster load, non-backfilling traffic. And so for this, I took a 2-day period looking at just normal client I/O on the cluster, and then comparing comparing a population of the storage nodes without the co-located, the standard Echo configuration, co-located RuxDBs, and then comparing them against the storage nodes I had redeployed with the hybrid OSDs. And so what we've got on the right hand side here is we're just looking at cluster read rate here. Obviously the read traffic is the thing that we echo for a couple of reasons that I'll talk about in the conclusion. But yeah, so we're looking at the client read rate. So this is let's say a 2-day window, mostly hovering around 40 gigabytes per second, with a couple of spikes up to over 100 gigabytes a second. So it was quite a nice sort of representational view of what Echo is doing generally, which I think made it quite a good place or time to observe. And then on the bottom, we're looking at effectively the read operations hitting the underlying hard drives. And I'll dig into these results in like a slide's time. But I think it's quite interesting to see that there actually isn't that much of a difference. Cool. So yeah, and sorry, the final thing to highlight about this, about how I did this analysis, and I think one of the weaknesses of it is this is quite heavily averaged in 2 different directions. We're both looking at quite large reporting windows, which mean that we're going to miss out on like temporal hotspots, and then also we're looking at the block device averages of like hundreds of OSDs. And so if there's a bunch of OSDs that aren't doing anything, and then one that's 100% utilized, I'm not going to pick up on that. We're just going to be looking at, like, as I say, averages. So although it gives us an idea of like the total cluster headroom, if there are particular hotspots inside them, I'm not going to pick them up, which may change the answer if I would have seen them. But anyway, on to write operations, because again, this was one of the ones I was like, oh great, there's like a real clear difference here. So here we're looking at a scatter plot of how much bandwidth, the write rate that the hard drive was doing along the x-axis, and then the number of write operations per second that it was also doing to support that. And again, you're looking at the clear difference between something that's just the data device in orange. You've got an absolutely consistent. All the I/O is the same size. So if you're doing more throughput, you're doing a few more IOPS, but it's very, very well controlled. In contrast, the co-located or the HDD only OSD, you've got an absolute it's a lot more volatile, and there's clearly a lot more IOPS required to do the same data rates, which it made a lot of sense. I think one of the interesting things here, obviously hard disk drives, and I mean these specific hard disk drives I was testing, they do actually support quite a lot of random write IOPS, or I guess write IOPS. So these have around 550 IOPS or write operations per second advertised, and that tends to be what we can see them doing. So there's a huge amount of headroom here, I think, is what I was trying to illustrate here. Interestingly, if you just take the not great linear fits here, the HDD only OSD would have run out of IOPS before it ran out of data, before it hit its advertised throughput rates, whereas obviously the hybrid OSD wouldn't have. So we would be losing theoretical performance here. As I say, it would set the HDD only ones would in theory saturate somewhere around 80 megabytes a second of throughput, which is not very much. Like less than half of what it could do. Having said that, that would be, if that was happening over the cluster, that would be somewhere around 100 gigabytes a second of cluster write IO, which far exceeds our wide area network connection and how fast we might be receiving data from places like CERN. So that's it's interesting, but it's not a particularly compelling factor for this cluster.
Sorry, Tom, could I quickly ask a question? Sorry. For your hard drive only data set, is this all using the same models of hard drives, or is this using the sort of heterogeneous last generation sort of cluster?
Yeah. Cool. So this analysis was done on, and I should have put the stats on it. But yeah, this analysis was done on a specific generation of the of our Echo hardware, the 2022 generation, which has I think they're 20 terabyte hard drives. So effectively the comparisons are all between identical hard disk drives and identical storage node configuration, just one of the configurations with flash for RocksDB and the other one without. Does that answer your question?
Yes, yeah, totally. Thanks for clarifying that.
Cool.
Tom, just as a data point, we are around like 30 minutes in. So just to give you like some reference.
I'm so sorry. Last slide.
It's fine. And then I have like a question. Does it mean that you're running with the right cache enabled on all the drives? So, one of the guidelines for Ceph, it's like always been like disable all caching that you can. But I understand that you're not doing that.
Yeah. So interestingly, this is with the write cache disabled in all of the, or at least last time I checked, I was confident that it was. Yeah. No, I remember it was a couple of years ago that it was like, yeah, you should probably not have the write cache enabled, and we checked. Yeah. I think there's sort of a I mean, hard disk drives are wild in all the things they can do to improve things. I think a lot of them have it's not a it's like a persistent cache in that it's like a bit of flash that can be used to effectively accumulate small writes to prevent you from completely thrashing the hard drive. That's my understanding of them. I must admit, like this is getting quite low level for me. But yeah.
Okay, but meaning that like the regular like write cache settings on HD Byrne is disabled.
Yeah.
As well for you. Okay.
Yeah.
I maybe misunderstood from the note then. Fine.
Yeah. Yeah. As I say, I must admit, this stuff like there's a lot of stuff going on underneath. Right then. So the final slide of results. And finally, obviously, this is where it all came completely unstuck. Looking at the read operations hitting the underlying device with the two different configurations. And I'm not a scientist. I can't really read scatter plots, but there's effectively for me, there's no meaningful difference here. The number of IOPS that are hitting the underlying block devices for the amount of cluster or amount of read, or the read rate that the cluster is doing. There's obviously a relationship there, but the co-location of the RocksDB doesn't. There's no difference between those two configurations. The same is true for all of the other ways I tried to plot this. Looking at latencies, there's no significant increase or decrease in the latency of the individual operations, which basically led me to the conclusion having co-located RocksDBs results in effectively no extra I/O access hitting the underlying hard disk drive under normal operation for this cluster. I guess that means that it all fits in memory somewhere or something very clever is happening. But that was where we ended up. So to sort of quickly conclude, for this use case, and specifically for the making sure we have enough read operations per second available on the underlying block devices, because that's our limiting factor here, there's no benefit to moving the RocksDBs off the hard disk drives. Where the benefit will continue to come from, and it's what we do already, is the making sure we have good application level caching and buffering to enable us to make sure the IO size hitting the underlying HCG Ceph cluster are large enough. So we're continuing to send sort of multi-megabyte reads at the Rados level. And then finally, as I say, this is something that is going to continue to become a problem if we continue to grow as a problem if we keep buying larger hard drives. I think we run quite large hard drives compared to some other Ceph clusters. I mean, they're large hard drives compared to our other Ceph clusters. And you are going to continue to get less and less operations, particularly read operations per second per raw terabyte or per terabyte. You then stick a wide EC geometry, like an 8+3 on top of that, and you've suddenly divided it by 10 again. And you're suddenly looking at a very small amount of usable operations. So we need to sort of keep thinking about this, and maybe change what we're doing if we need to. But yeah, I think that's it. Thank you. Sorry for, I guess it was as quick as it. Yeah. Anyway.
Thanks for a very nice presentation, Tom. Are there questions?
I got a question I was just wondering, Tom, the sort of size of the objects you're pushing up and the size of those reads, whether you could sort of mention what sort of like size that is, and like, are they reading effectively big objects or is it quite small ones?
Yeah. So as I say, we're effectively using LibRedos directly through a client library called LibRedos Striper, which, as the name suggests, it's basically LibRedos with a small amount of striping and chunking put on top of it to enable you to write consistent size objects for whatever the client object is. So we use that, and for this we're targeting 64 megabyte chunks or stripes, depending on what you want to call them. So the underlying Rados objects are all 64 megabytes, or up to 64 megabytes. And then so all of the writes, and I guess I should say, these are all objects are effectively immutable from when they hit the cluster. So we can expect writes to happen at the 64 megabyte object size, and then reads, depending on where the read is coming from, we have a few different effectively prefetching and block sizes, depending on whether it's like direct IO, someone who's like directly accessing the file on the remote storage, or whether it's like a whole file copy going somewhere else. There'll be different block sizes. I had sorry if people can still see my slides. So this is a sampled. So this plot on the right, this is sampled, but this is effectively the operations actually hitting the underlying Ceph cluster. And so most of about half of the read operations are full 64 megabyte object accesses, and then with some 16, some 8 megabyte, and then the remainder sort of like small direct access or like ends of chunks type thing.
Okay, thanks for that. And also thanks for giving the presentation. It was really interesting. So thank you for that.
Thanks, Ivan.
I have a question myself as well. The others line up of theirs. So I hear that you're actually starting for like a new, let's say, new campaign for a new generation of OSDs. I guess, did I understand correctly? Are you actually? Have you found any vendor that sells these mythical? Because I haven't seen them for real. Dual actuator drives. So following up on your lack of IOPS, but it's afflicting the larger HDD. There seems to be a kind of like solution, which is probably not the solution, but still could actually mitigate the problem. But so far, I've seen no vendor actually providing those. And funny enough, like HP nodes have like a setting in their controller that actually tells you whether it's a multi-actuator drive or not. But when we ask them if we can have some, they say, "Oh, we don't have them."
Yeah, no, I certainly haven't seen. Nobody's been willing to give them to us or even suggested them. I mean, I think, and I'd like to highlight like one of the problems but one of the challenges we have here is the way we buy these hardware generations going out to tender means that like there is unless we figure out exactly what our performance requirements are, like say per raw terabyte, and then put it higher than than what we would get with the big single actuator things, we're just going to continue getting the cheapest hard disk drives, and it will probably change the cost significantly if we were to try and push for something else. So I think we have to be quite careful here. No, I haven't seen them in. Yeah, nobody's willing to give them to us. Someone was saying that the hyperscalers have bought them all, but yeah. Anyway,
has anyone in the audience seen them for real? I'm curious at this point. So Pierre was asking if you have a link to the slides. Unfortunately, we don't yet have like a repository to put our stuff inside. I think we're better off like probably just having like a GitHub repo or a GitLab one where we can actually upload all the slides. So I guess that's going to be the easiest solution. But in the meantime, if Do you have, by any chance, a way to provide the link to your slides, Tom?
Yeah, I will. Yeah, I will. I will get a link in the chat before this ends. Cool. All right, I'm gonna stop sharing, I think, somehow. Cool. Thanks for listening, everyone.
Cool. So additional, let me see if I managed to share the screen myself, given the limitation apparently of my browser. It's this allow. Okay. So can you see the pad by any chance?
Yep.
Nice. So there is not much. Well, there are a couple of additional topics. So one I wrote, it's about Ceph RBD, and then there is another one for Ceph ADM versus manual deployment. So I'll be very quick with mine. So lately we had some issues with so switching, let's say, backend or like yeah, entirely. We have a cluster that serves RBD. RBD images, so RBD block devices for VMs. And so far we've been afflicted by a very weird failure mode by which one of the RBD node actually encounters some kind of kernel bug. And instead of dying completely, it starts to basically limp along. And this actually, so, and Ceph does not recognize this very well. And since we have, it's a very small cluster and the monitor are co-located in these nodes, this ends up being like adding latency to the monitor until the cluster becomes basically unusable and the node is actually rebooted. So it's a very weird failure mode. I never experienced it before. So I was wondering if you're just unlucky or if someone has seen it on their own infrastructure.
Do you have any symptoms like slow ups?
So well, yeah, but well, so you see like you start see OSDs that are actually marked as down, which I mean is fine. It's expected. But then the problem is that the node never completely dies. So while the OSDs actually are marked as down and they are basically no longer used, the monitors keep on actually being alive, and it's never really kicked out of the quorum. So there is like this unresponsive monitor in the quorum that actually basically triggers or slows down all the requests from the clients eventually when they need to actually contact the monitors. So it's a bit like so we start seeing like some hiccups and then like some other hiccups, some clients that have stale mounts and eventually like most of the IO stops, but not all. Because if a clients already have them up and doesn't need them on, then it still go on working. So it's a bit yeah. We think it's due to the fact that the monitor is actually not completely dying in this scenario, and therefore like yeah, Ceph reacts very well to losing OSDs, but the monitor not so much, or not losing the monitor actually creates this issue.
Yeah. So does it? Sorry if you've already said this. Does it? I mean, as you say, if like the monitor is sick but still trying to do stuff and then black holing stuff, does it get better as soon as you kill the monitor? And
yes, yeah. As soon as we reboot, we hard reboot the node, because sometimes it's not even reachable at that point. Yeah, everything goes back to normal.
Mm.
It's just super annoying because we haven't found a way to actually have this failure mode scenario actually take care of itself. So it needs a manual intervention to actually kick out the monitor from the cluster. And funny enough, like 2 out of, well, no, not 2 out of 2. It happened 2 times so far, and one time we also lost the monitor store, so we actually had to remove a monitor and install it basically because it lost all the monitor information. It could not rejoin the cluster anymore. So it has been a little bit weird. So it's on Quincy, so we want to try to also upgrade and see whether this improves in terms of resiliency. But yeah, so far we haven't found any pointers to.
Matteo, sorry, is this happening on one node in particular, or this is like a class of, it's like a hardware generation that you have in your data center, which behaves similarly?
So that's a good question. So I was not part of it happened not only twice so far, but it's quite severe. The effect is quite severe. I'm not 100% sure. So it's a 4-node cluster, so super small, because it hosts just the root disk for VMs that we use via RBD. And I'm not sure, 100% sure it happened both times on the same node. But the trigger of it I can find, and it's actually unrelated to Ceph. So it seems to be like some kernel bug that we trigger with this. I'll link actually the log line in the chat.
Because from the top of my head, the mon, I do not think that you can like preemptively mark it down or move it away. For the OSDs, you have this configuration parameter, which is OSD max markdown count, which is basically a threshold that counts the number of times that an OSD flaps up and down over a period of time.
Mm-hmm.
So if this happens too frequently, you can set this to a sensible threshold for your environment and basically say, okay, the OSDs are down and they will stay down unless you actually go and do some manual intervention to bring them back. But if the whole node freezes, or okay, I understand it's not really freezing, but if the whole node suffers, I mean, from the top of my head here, recently we have seen kernel bugs with XFS and with some InfiniBand, but none of the two are clearly related to the symptoms that you are reporting. So sounds new.
So additional additional bugs, but not this one. Okay.
Yeah.
Anyway, so. I'll link. I'll paste the kernel line because I think it's interesting. If someone maybe has seen it in a different scenario, but yeah, but that was just it. I was just curious to see. Of course, like a mitigation is to just move them on away from the collocate. So do not collocate them on this problematic node. So at least we can have like more resilient mon cluster. You can kick out a mon. You just delete it from a cluster. It's a bit annoying because then you have to reprovision it. But there is an extreme measure that you can take
what I was
case
referring
nothing
to,
else works.
But what I was referring to is that I don't think there is such an option like OSD max markdown count for the mons that you say, okay, if a mon is like flapping back and forth at some point, you just assume it's down and it stays as such.
So the bug, anyway, it's a kernel null pointer, the reference. So maybe it's just the kernel that's actually
sounds fun.
Is complaining, but I can actually list this. Okay, so there was another topic in the pad. So who wants to bring it up?
Yeah, I tossed that one in there. I think we talked about this sometime last year, but like, have people's feelings changed on Ceph ADM versus manual deployments for clusters? And I think, the case used to be most people shied away from Ceph ADM and didn't want things really running in Podman or Docker. Just curious what people are doing these days, or if it like depends on cluster size. If it's a small few node cluster like your IBD clusters, maybe Ceph ADM is okay, but like if you're doing multi-petabyte clusters, you might still be doing manual deployments. So just curious what people are doing.
We're still doing purely manual deployments. I suppose in a way we're quite keen to keep our cluster quite simple, so we don't really want to introduce like containerization for a lot of our stuff because we're concerned about just adding effectively another abstraction layer on top of it.
Yeah, that's my similar big concern. I recently had to deploy some for small clusters for like Kubernetes RBDs and Cephfs, and I went and did Ceph ADM, but I'm not entirely sure I'm happy about that decision now.
I can bring data points. Sorry.
Oh, sorry. I was just wondering, Kevin, whether you noticed any like performance differences or any sort of different behavior between your sort of Ceph ADM deployment or your manual one.
We haven't pushed the clusters hard to get like any good performance metrics out of them. I mean, the main pain thing is just like that abstraction layer of Ceph ADM doing things. Like I miss the manual deployment method I used to do, and it's just a little more. It's supposed to be easier to deploy things, but like the administration side, when things go wrong, just seems to be a bit more of a pain sometimes.
We've started a process of migrating from one to the other to Ceph ADM, and I'm still a bit torn. I'm more familiar than some of the other people that run our Ceph clusters with it all, so I'm quite comfortable with how it's set up. Whereas the new clusters set up by the new people, they're like, hey, Ceph ADM does this for us, and hey, look, here's this wonderful set of playbooks that Stack HPC publish that we can use to deploy them. Like, yeah, that's great. You get a cluster, but do you understand it?
Mm-hmm.
Watch the performance is fine. It's operating well. It's reliable. Again, the abstraction and getting into logs is a little bit more of a fiddle than I'm used to. But is that me and my familiarity? And I like log files, and somebody else likes systemd journals.
I can bring another point as well. So we are also using Ceph ADM. Actually, we are quite happy with it. It's flexible enough for our use case, but then I guess it depends. I guess also there was some scaling issue that we don't have because we have like 20 nodes, 25. So I guess there's also that to take into account. But for our use case, for example, it's actually quite nice. It takes care of most things. Also, like what I was mentioning before with the monitor deployment, I had to trick Ceph ADM to redeploy the monitor, but then it did it by itself. So, so there are a lot of things that you get out of the box. Sometimes
I should
get some
definitely
quirks, but yeah.
Yeah, I should definitely echo that. Certainly, the efficiency of having containers instead of VMs for some of our separated daemons, the flexibility to move things around with the controls that Ceph ADM gives you. There's a lot of benefits there. There are some technical challenges and some technical advantages, and all of those things come out pretty good, I think, on the whole. But I think it's some of the quasi-technical, organizational and procedural stuff and familiarity that is open to a lot of interpretation.
Yeah, one thing I found I did like was like being able to write the declarative YAML files for like each of your your host specs, your OSD, your mon spec, NDS, and just like up Ceph ADM whatever or Ceph Org apply it was kind of a nice feature of that.
Yeah, I definitely echo that. I think so we run a mixture. We have a couple of Ceph ADM clusters now, and then the big cluster I was talking about, that's bare metal deployment. Yeah, I think Ceph ADM definitely, if you're willing to understand what it's doing, it can make life a lot easier. Up until the point it breaks, I guess is the thing. But we've had good experiences with our Ceph ADM clusters. And I'd echo the actually being able to define like your OSD deployment strategies, like depending on what type of host you're on and stuff, is it just makes life a lot easier.
Yeah, I think my big problem started out as just like coming back from like the Hammer or Giant days of Ceph, and it was just a learning curve to figure things out.
Yeah,
we deployed it. Sorry.
No, please go ahead.
I was going to say we deployed before Ceph ADM came along, and we essentially created our own salt-based YAML files at the time, and we're still using those to this day. and I don't think we see any reason to switch to Ceph ADM at this point. We pretty much those YAML files that you're talking about, we have them in our salt states, and we can just deploy it. A new cluster on just reapplying the same states and adding those something like that. Processes. Each node. I think one of our bigger worries right now is our clusters are Ubuntu-based.
I'm not sure if I'm the only one, but I cannot hear you very well.
Yeah, same here.
Can you repeat the last sentence, or the last couple of sentences, because I think they got a little bit jumbled up, I guess, of connection issues.
Can you guys hear me better?
Kind of, yes.
I'll try to speak louder. I was going to say, yeah, we are using those salt states, and I don't see a reason for switching at this point. Our biggest worry is the latest Ceph clusters. The Ceph version is there. Apparently, they're dropping. There's no more packages being provided, as far as we can tell. And that's kind of making us wonder if we should try Ceph ADM just because of the Docker provided, the Docker container versions. But otherwise, I don't see us ever going to Ceph ADM. Right now, we're debating between try the Ceph ADM provided Docker containers or use the Ubuntu provided packages for Ceph.
Yeah, and I think, sorry, that was still a little garbled, but I think if I got what you were saying, I think that's one of the big pushes for us is we've recently been through a operating system upgrade, and the idea of having to immediately jump on another operating system upgrade cycle because of because of the versions of OS that the Ceph version support. Being able to decouple that and not worrying so much about making sure we're not worrying about our underlying OS version. I think that's one of the big benefits for going to Ceph ADM for us.
Before, we can go on a few more minutes, but before actually we reach the 5 mark, before actually maybe other people, people have other appointment. Is anyone that would like to volunteer a presentation in 2 months' time? So this is actually, we meet once every 2 months. So that will mean July, end of July. It can be very there's 10 minutes talk about something that you found out and you find interesting. Also, you don't need to actually volunteer now, but please consider actually doing that. So the idea here is that we make the user group interesting by providing additional let's say pointers and interesting bits of information on Ceph. Sorry if I interjected.
I see Pierre raise your hand if you wanted to go ahead.
Oh, that was for replying to the Ceph ADM topic. I mean, we could maybe talk at some point, but I have to think about what we could discuss. At Stack HPC, we've moved to Ceph ADM from Ceph Ansible. It's a process that we started maybe 2 or 3 years ago. I don't remember exactly the timing. So we're fairly happy with it. It has some issues sometimes. Maybe my main issue with it is that it can be a bit slow when you ask it to redeploy a service, reconfigure a service, and it has to iterate over all the nodes. But in general, it makes life quite easier. Just managing every service with a YAML spec and some labels on the host, and we use it to manage fairly big clusters, at least big in number of OSDs, not necessarily of number of nodes. So yeah, it could be improved, but I think we like using it.
Mm-hmm. Cool. Well, it's good to hear people's input on all that.
Go ahead, sorry, Kevin. No, go ahead, Kevin.
Well, I was just saying, yeah, it's good to hear that. Like, I think a year ago when we had a similar discussion, people were still a bit more wary about Ceph ADM, but it seems like folks are coming around on it. So it's kind of cool to see that.
And it's great for upgrades as well. So I just did an upgrade from Quincy to Reef on a 10 petabyte cluster earlier this week, and it just, for the most part, worked very well. We just had one issue where one node had, so it's a setup where all the disks, well, all the spinning disks at least, are in a separate enclosure. Sorry, I'll put my video. They are in a separate enclosure to the server. It's one of those big Dell M something array. And I don't know the connection between the server and the enclosure was probably unhappy on one of the hosts. So every command that the host was working fine in terms of I/O, but when it was scanning the bus for disks, those commands were timing out, and it just slowed down the upgrade completely. So we were at the step where we had updated the mons, and it was updating the mon map on every client, so including every OSD, and on that system we had almost 1,000 of them. So usually it takes just a few seconds for each OSD, and this one was on this host it was taking a minute or 5 minutes sometimes to update the mon map for one OSD. And it's only when I saw the error messages in the dmessage log that I realized there was something wrong. So the fix was simple. It was just rebooting that host, and then it became snappy again. But it was interesting to see the behavior of Ceph ADM during that time. It's just it couldn't process other commands, or was doing it very, very slowly. So I had run a command to redeploy an ingress service, so the HA proxy and the KeepAliveD services, and we have 18 nodes, and it just did one in 15 minutes, and it just couldn't process. I don't know, there's some ordering of the tasks that just didn't work. So maybe the parallelism could be improved. If it can't make some progress on some task, it could still execute the others, and it just doesn't do it at the moment. And of course, if you're doing manual Ansible or Puppet or some other provisioning, then you can skip tags. You have that control. Ceph ADM is more like a black box where you say, I want to reconfigure this and that, and it does it, but sometimes you don't know where it is. You don't have control over how it's doing it and how quickly. And yeah, I would say that's my main disappointment with it. But overall, fairly happy.
I think that's the concern of Ceph ADM that I have, that I struggle to describe. When people talk about their reservations about containers, I can take or leave containers. I'll take them if I need to for Ceph ADM. It's that, we've got control of our automation system. So, and we're relinquishing some of that for this actually quite well written and quite well tuned, but not quite as well tuned as for our system as our automation that we've built.
Yeah. The containers are completely fine. We don't have any problem with them. Yeah, it's the orchestration bit which can be a bit too magic, and you don't have that control that you normally have. But it's a trade-off. It's also quite powerful in some other ways. So
yeah, I agree. It's like it is very black boxy at times, because it's just you try to apply something and then it might happen in 10 or 15 minutes, or it might not, and then you start digging through log files. I wish there was a bit more transparency of like, here's my Ceph ADM task queue of what I'm working on, and here's the order of things, or like something to see what that black box is doing.
And in some ways, the relationship between the user and the dev community is always going to make that a difficult problem, because the devs have their priorities, the corporate customers have their priorities, and the communication between them and saying, hey, can we have Ceph ADM more transparent? You know, what that message ends up being implemented as might be something else.
Yeah, I think just from my relatively limited experience, like so much of the power of Ceph ADM, of the Ceph ADM orchestration, is that it is so tightly coupled and it can do things fairly quickly and efficiently in ways that would be quite hard for an external orchestration configuration tool to do. But yeah, then there's also a hefty amount of what on earth is the manager doing type thing. I mean, the manager logs are pretty good. Like when you watch the right thing with the debug statement on, like you can kind of tell what it's doing, but it's I guess it definitely could be better. Yeah.
Rico, do you have?
Yeah, so okay, we do not massively use Ceph ADM. We just use it in a couple of test clusters to do crazy things like create 50 file systems with 10 MDSs each. And this is extremely practical because you can instantly collocate daemons and it does all the job behind the scenes for you. This is really amazing. It is also true that when we were installing these clusters, we hit like a couple of bugs straight in the face, which are related to Ceph ADM, like being unable to guess what is the net mask of the public interface. And this led to some health warning and health error messages because then it wasn't able to deploy additional daemons, etc., etc., etc. So experience can be, I guess mileage can vary. It can be very bad, it can be very good. I don't know if, like, I would be very interested to know if you are using some features or plan to use some features which are let's say delivered via Ceph ADM only. Like at the last Cephalocon, it was presented work about I think SNB exports or NFS exports, or maybe both. I don't remember which of the two. On top of CephFS, and this would be something that only Ceph ADM would be able to deploy for you. It does all the work, and you do not have RPMs or other packages to deploy what is needed. So that's like a major difference compared to what I was used to see up to now, where you see exactly the same stuff in container-based deployments and package-based deployments. Now it seems that things are like branching off a bit. Then okay, I do not have first-hand operational experience with Ceph ADM, but the isolation that the container brings, it's very good and very bad at the same time, because I think that over the last 1 year, just by reading at the mailing list, it has been demonstrated that there was an issue with a clone 3 function in the kernel, and therefore some containers were not compatible with some operating systems, or at least particularly old kernels of the hosting infrastructure, which somehow breaks the isolation between the two layers. And on the other, let's say in the opposite direction, as far as Ceph is concerned, I think the container gives you the reassurance that what you deploy will actually work, because recent builds are, maybe you have seen this problem with OpenSSL 3.5. If you're using RPMs or if you're trying to deploy very recent squids, I guess, so far on Enterprise Linux 9. This actually doesn't work. DNF will complain about dependencies because the software was built with OpenSSL 3.5, and actually on EL9 you only get 3.2 or 3.4. So there are like incompatibilities in both directions, and I'm not sure where the sweet spot is precisely. So if you have first-hand experience about this, I'm very curious to know, because these are typically things that you do not realize until you install it, and then you say, "Ooh, we have a problem." Yeah.
Very well. So if there are no additional follow-ups or no additional points, I think it's time to part ways. Thanks everyone for joining. Please, so we'll try to create the new Etherpad soonish. So if you have like a presentation you would like to give, you can just add it to the Etherpad. Even if there are more than one, then we can also decide who wants to do it on the. We can please put an email so we can contact you and understand whether it's working for you, or so we don't find ourselves waiting for a presenter indefinitely. So the as I was mentioning, yeah, so it's every 2 months. We have I put in the Etherpad the link to the actually index of all the other Etherpads if you're curious to see what was discussed, which point were actually touched in the previous iteration of the user group. And I don't have anything else. If someone else has some final comments, I would like to.
Do you usually?
Yeah, sorry.
Tom.
Sorry, Pierre.
Do you usually upload the video? Because I found there is a playlist of the Ceph Science user group on YouTube, but the newest one is 2 years old.
Yeah, so I think there was a switch, but maybe Kevin knows better about this. There was a switch from Big Blue Button that had a better way to upload videos to.
Yeah, we used to stream it directly to YouTube, and Blue Jeans was the old application.
Oh, Blue Jeans, sorry. No.
Yeah, and that worked fine, but ever since the move to Jitsi, it's never been great. And sometimes the Ceph community folk don't respond to here's a video or please help us. So we're trying to work on that and get them back up on the Ceph YouTube channel.
Okay, thank you.
So there's, as a follow-up on this, there's a new Ceph community manager. So there has been this Dev Plus user meeting last week or a couple of weeks ago, and the video landed on YouTube pretty quickly. So maybe we can get this one on the YouTube channel as well, assuming the recording has worked. Fingers crossed.
Yeah, because they do those user plus dev monthly meetup, and yeah, they show up regularly.
Right. Yeah. Exactly.
And I think they're done with. It looks like they're done with Jitsi as well.
Was it Google Meet last time? I don't remember. It's possible.
For the application, the meeting app?
Yeah.
They were using Blue Jeans for a long time.
Yeah, but okay, I can check that.
Yeah.
But yeah, we'll try to actually get the videos back online. And also, so if someone wants also to contribute to the chairing of a meeting, please drop a line in the Etherpad. It's also something that we are keen to share with the rest of the community. It's not like that we want to be the overlords of this user meetup. So. Perfect. Sorry. Go ahead, whoever was talking.
I had one really boring piece of any other business, I guess. I was excited to see that there was going to be another Quincy point release, I think.
Oh, that's interesting. I thought that it was end of life.
Yeah, well, it was Gregory's message this morning that highlighted it. There's some bug that I think they deem worth fixing. Enrico, do you think that's something that, because for the EL8 Quincy stuff, obviously they're no longer packaged by Ceph. Is that something that you think that CERN will produce RPMs for?
I'm building them at this very moment.
You're a hero.
Yeah.
Thank you.
So they should be out in 1 hour or less. Yeah. This is from CERN Linux Soft though. It's not, we're not, because we cannot give the packages to them because the signing key, GPG signing key of the packages is different, and these RPMs come with no warranty whatsoever, in the sense that the software is tested according to Ceph upstream. The RPMs are not tested. So the RPMs is like me, I'm installing them on one cluster, and this works. But you see, it's a bit of a different thing. So yeah, no, they're being prepared. They should be out soon.
Cool.
There's an email from 17 minutes ago from Yuri Weinstein.
Yep.
It's been released.
Have you actually hit the bug? Have you hit the bug? So if you look at the
change
log, the new release is 1 Git commit with 3 lines for bouncing the log sequence number on BlueFS. We hit that. It's not nice, but it doesn't produce any, at least from our experience, it doesn't produce any data corruption, in the sense that the OSD crashes and then it comes back, and you hopefully don't crash it again. Yeah. Just to give you the some more context, we have upgraded 15 clusters, and we've never seen that. We have upgraded our biggest object storage cluster, and first disk server, we hit it straight on 20 OSDs out of 48. So it really depends. So there is.
So you're saying the other ones are not Rados Gateway clusters, but this one was?
Okay. No. The others were also RGWs. The others were pretty much anything, and we never see this happening. So there's like a chance that if you have never seen this happening, you will not see this happening. But maybe upgrade. I don't know. It's The fix is pretty easy. So, I honestly think that the fix fixes it, because when we hit it, the assertion is very clear, and we built a patched version with precisely this very same patch, and nothing has crashed anymore. So there is decent, there is a decent likelihood that the patch fixes the problem.
Yeah. So we literally took some decisions today not to, because we've got some repo problems. We've only got 17.2.8. So we decided not to go to that, and we're going to wait for 17.2.9, and so it's out now. So that's great.
Yeah, this to me looks also extremely weird, because in what was expected to be the last Quincy release, so 17.2.8, they actually introduced new things that later demonstrated to be buggy, and then they had to revive it to put this patch on top, which I'm not sure.
Hopefully they learned from that mistake.
Well,
don't add features to final release. Anyway, but yeah, no, that's all good news.
Yeah,
and that means it'll pave the way for us to get to Reef.
I'm not sure if I should try to close the meeting again, or
just silently fade away.
I was kind of tempted to ask: are there places where these conversations happen? Are you guys on various chat channels or email, or you're all in your own institutions and whatnot, mostly talking.
I think this is it for me, certainly.
Yeah, for me as well.
Do you have something in particular in mind? Like
no, I mean I hang out on the Ceph Slack. I read the email list, and there's a few channels in Ceph Slack now for different purposes. But no specific suggestions.
No, I think we're all doing the same. User mailing list is very helpful. Slack is very helpful. Reddit has proven to be very helpful to me. So just
can someone put the Slack link in the chat? Because I think like I had like a multi-month project of actually joining, but I never done it.
Yeah, I only managed to join.
Oh, it's there
this week.
Reddit is really interesting. There has been some terrible advice there over the past year or two, and my colleague prefers Reddit to everything else, and I've had to be a little bit cautious in my responses to him going, oh, they said I should whatever, and but I think it's got a little bit better. Enrico, you said you've had some good experiences there.
Well, this problem with 17.2.8, like the first time I read about it, it was the first hit returned by Google on Reddit.
Yeah.
Then of course, if you're more specific, like you Google for the assertion or you go to the tracker, etc., you find better sources. But like the title was like stability issues since upgrade to 17.2.8, and I was like, okay, it must be this.
Yeah. Yeah. Well, it'd be nice to think that the signal to noise ratio is improving there. Yeah, well, that's evidence of a good one. So cool. All right, thanks everybody. Good night.
Cheers.
Bye
everyone.
Bye.
Thank you. Bye.
Cheers.